Today we are learning about properties of logarithms, and I'm going to try to boil this down to the simplest shortcut possible. Is that okay with you? Are you sure? Okay. First, we have to actually talk about the properties. There are three properties of logarithms that we're going to be using. These are tied to properties of exponents, so you might see some similarities. If we've got the log base b of uv, what's happening between u and v? Multiply. If there's multiplication inside the log, we can break it up into the log base b of u plus the log base b of v. Multiplication inside the log can be broken up into addition between the logs. So u and v both get their own log. Notice u and v both have logs with the same base because that was the original base from the original log. So if multiplication breaks up using addition, what do you suppose division is going to do? Subtraction. So log base b of u minus log base b of v. These are definitely tied to properties of exponents. If you're multiplying the same base, you add the exponents. If you're multiplying inside a log, you split it up and you add the logs. If you're dividing with the same base, you subtract the exponents. If you're dividing inside of a log, you split it up with subtraction. The next one is my favorite property because it really helps us in solving logarithms. If you have an exponent inside the log, that exponent is going to move in front and become a coefficient multiplied in front of the log. So n times the log base b of u. The reason that we practice these properties of logarithms is in the process of solving logarithms, you're going to need to know these properties so that you can expand and condense whenever necessary. If I waited until then to teach it to you, it would be way too much information and it would confuse your brain and you'd end up hating me and hating logs. And I don't want either of those things to happen. I mean, I guess you can hate me. It won't like destroy me or anything, but I'd prefer it if you didn't hate me. But I definitely don't want you to hate logarithms. So I want us to practice these properties and get so comfortable with these properties that by the time we see it in solving, it's not a big deal at all. So expanding the expression, we have log base 2 of 7 times x to the third divided by y. Technically, we should do a multi-step process where we say, okay, this is multiplication, so we're going to take those and add those together, and then. So here's my shortcut. How many things are inside that log? There's a 7, an x to the third, and a y. There's 3 things inside the log. So I'm going to write out log base 2 of 7, leave a space, log base 2 of x to the third, leave a space, log base 2 of y. There are 3 things inside the log, the 7, the x to the third, and the y, so give each of them their own log. The 7 and the x to the third are being multiplied together. So what symbol do you suppose we're going to put in between those 2 logs? Addition. Then we divided by y, so what symbol do you suppose we're going to put in front of the symbol with the y? Subtraction. Okay, here's the general hint. Here's the shortcut. If it started out on the top, then that log must be positive. If it was on the bottom, then that log must be negative. Top positive, bottom negative. Make sense? Sure. Let's try number 2. How many things are inside this log? We've got 25. We've got x to the 6th. We've got y. Oh, hey, we need to probably finish the first problem, don't we? Yeah. Does anybody see anything in the first problem that we talked about in the properties that we might be able to do? Like maybe the thing that I'm tapping? The power property. If there's an exponent, like this 3, it needs to move in front of that term. Not in front of the whole thing, in front of that term. So our final answer is log base 2 of 7 plus 3 times the log base 2 of x minus log base 2 of y. And that's done. So number 2, there are 3 things. There's the 25, the x to the 4th, and the y. So I'm going to write log base 5 of 25, log base 5 of x to the 6th, log base 5 of y. These things are all multiplication. There's no denominator, there's nothing on the bottom, so all of these logs need to be positive. The first one's positive because it's just assumed that the first one's positive. We need to put a plus in front of log base 5 of x to the 6th, and we need to put a plus in front of log base 5 of y. Is there anything else we can do? Bring the 6 down. So we have log base 5 of 25 plus 6 times the log base 5 of x plus log base 5 of y. And yeah, we kind of went into number 3. We'll do number 3 down here underneath. That'll give us some extra room. Okay, now I do need to take a moment because technically the answer that I just boxed isn't complete. Can anyone think of a way to write 25 using exponents? 5 squared. So log base 5 of 25 is actually log base 5 of 5 squared. And then what would happen with that square? It would go in front, so this would be 2 times the log base 5 of 5. Does anyone know what the log base 5 of 5 is? 1. So this becomes 2 times 1, or just 2. So really, this should say 2 plus 6 times the log base 5 of x plus the log base 5 of y. Now, here's the deal. Today, I really only care about you practicing the properties and getting to this answer. This 25 not being fully simplified thing is kind of a technical detail that I don't care about right now. I don't want to get caught up in the particulars. I just want you to practice the properties. So for today, ignore those particulars, just practice the properties. So I would consider that answer to be done. Number 3, how many things are inside that log? There's more than 2. There's more than 3. There's 4 things. 9y is not one thing. 9y is 2 things. It's 9 times y. 1000x squared is 1000 times x squared. So there are 4 things in here. What base does this log have? No base, which means base 10. We don't need to write that, so don't bother writing it. Log of 9, log of y, log of 1000, and log of x squared. This is a problem where the shortcut is really going to help you. Log of 9. The 9 came from the top, so that log needs to be positive. It's in the front, so we just assume that that's positive. We're good. The y was on the top, so that log needs to be positive, so put a plus in front of it. Where was 1000 originally? Bottom, so that log needs to be negative. Where was the x squared originally? The bottom, so that log needs to be negative. If you look up online how to expand this log, they would probably have like 4 different steps with parentheses and all sorts of crazy things, and then it would boil down to this. So the shortcut is if it started out on the top inside the log, then that log needs to be positive. If it was on the bottom inside the log, then those logs need to be negative. Okay, last step is fix the exponents. So our final answer is log of 9 plus log of y minus log of 1000 minus 2 times log of x. As you get familiar with these properties, you're probably going to be able to write the second step without writing the first step. If you see that there's an exponent, you can go ahead and deal with that as you're writing it out. Now technically, for those of you who really want to go further with this, 1000 is 10 to the third, so this whole term would end up simplifying down to just 3. But details, we're not going to focus on that. Okay, everything that we do in math, there's a way to undo it. It's the circle of math. Everything we do, we can undo. So now I'm going to give you something that's been expanded and ask you to condense it back down to just 1 log. And this is where that shortcut is really going to help you. So first thing you want to look for is any coefficients, any numbers in front, put those back as exponents. So this is log of 6 plus log of 2 squared minus log of 3. So first thing, get the exponents back where they go. Okay. I see plus and minus, so I know that there's going to be a division bar inside my log. 6 comes from a positive log, so 6 goes on top. 2 squared comes from a positive log, so 2 squared goes on top. 3 comes from a negative log, so where does 3 go? On the bottom. I want you to try number 5 on your own. First step, take the coefficients and move them back as exponents. 7 squared comes from a positive log, so 7 squared or 49, you can write either way, will be on the top. X to the 5th comes from a negative log, so x to the 5th will be on the bottom inside the log. Now try number 6 on your own. Our first step, log base 8 of x squared minus log base 8 of 5 minus log base 8 of y to the 3rd. All of these are going to be inside log base 8. X squared comes from a positive log because there's no negative sign, so it must be positive. So x squared on top. 5 comes from a log that is negative, so 5 on the bottom. Y to the 3rd comes from a log that is negative, so y to the 3rd on the bottom.